All right, folks, welcome to P.3. This is actually going to be one of the easiest sections that we have, period, in calculus. There's not even that much that I'm going to be writing down because it's all super straightforward. It's all stuff that you guys already know how to do, so I'm not really going to waste too much time. So what I'm going to do, or what I really suggest to you, is that you have your book open next to you right now while you're working through it, because I think that's going to be the easiest way to go about these problems. If I see something that I need to, I'll write them down so that way you can see them. But your book is going to do a great job telling you everything that you need to do anyway. And again, this is all stuff that I expect you to know right now anyway, so there's really not that much relearning that has to happen. The things that this section wants you to be able to do are plot points in a plane, which literally just means be able to put X and Y on a graph. So if you have the point -2, 5, you go left 2, up 5. That's what it's asking you to do. So plotting points on a plane are things that you should already be able to do, so we're not really going to talk about that too much. If you look at a scatter plot, this is one that might be a little bit trickier, but again, we know how to do this. We spent a lot of time on this last year, so I know that it's something that you've been able to do before. But when you plot something on a scatter plot, you have a graph, you put the points down, and then you look at the general trend. The big things that I want to mention to you, and as I share my screen with you, because it's something that you might have to kind of remember, is we have an R value called, or a correlation coefficient. The correlation coefficient is represented by the letter R, and it's between -1 and +1. And this is when -1, it's a very strong correlation. It looks like that. -0.5, as we get closer to 0, it starts to spread itself out a little bit more. 0 should have no correlation, so these points are just all over the place. And then this is just going to mirror image as we move towards the positive direction. So this is what the correlation coefficient looks like. If you remember back to calculus or to algebra 2, we actually were able to compute these based on your calculator. You just had to turn on the diagnostics, and I'm going to be talking to you about that in a second. But the big thing with this in this book is it wants you to be able to sketch a scatter plot and then possibly be able to predict things. In order to predict things, you need to create a line of best fit. Now that best fit line, you can do one of two ways. You can type things into your stat. You can enter your whole list. So I'll show you what that looks like on here if you don't remember. So if you look on your calculator, your calculator has a list. If you hit the stat button right here under delete, hit enter, you can put these things into a list. Now this is actually a scatter plot because this is what we're doing in algebra 2 right now. So if I want to find my scatter plot, here's a random set of values. And if I hit stat again, arrow over once, and hit 4 for linear regression, this is actually going to give me the equation of the line of best fit. So this would be the best fit line. If you want to know what the R value is, this may be something we use, may not be something we use, but if you want to do this, what you're going to do is you're going to hit second 0, hit the matrix button to get to D for the catalog, and then scroll all the way down until you find diagnostic on. Hit enter twice, and it will turn on R values. So now if I do the exact same thing that I just did, go to my linear regression, it's going to give me my R value, and that R value is almost 1 because it's almost a perfectly straight line. Okay, so those are the things that I want you to remember from best fit lines. You can use best fit lines to make predictions. You can use those things to kind of figure out what's going on. Pretty easy. Okay. The next thing that this wants you to be able to do, or the book wants you to be able to do, is wants you to use the distance formula. Remember, with the distance formula, it looks like this. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. Pretty straightforward. Okay. Now in the book, it gives you, or it tells you, it works through the proof of how this works using the Pythagorean theorem. If you're interested, give it a look. If you're not interested, gloss over it. It's no big deal. Should be a pretty straightforward concept. Remember, this always has to be positive. The two biggest things that I see are that people put X's and Y's in the same parentheses. You can't. It has to be all X coordinates here, all Y coordinates here. The next thing that this wants you to be able to do is verify right triangles. What that essentially means is your numbers should be able to work in a Pythagorean theorem. So if you have your distances, so if you look at example number 4, it actually starts out giving you 3 points. You have to find the distance of all 3 of those points and then plug those into the Pythagorean theorem. If they work, it's a right triangle. If they don't work, it's not a right triangle. It's not rocket science. It's something that you guys can already do. Okay, so I won't waste your time looking through examples because, again, it's stuff that you're really good at already. The next thing is the midpoint formula. So you have the midpoint is x1 plus x2 over 2, comma, y1 plus y2 over 2. This is the midpoint. When you find the midpoint, it should be straightforward, okay? And then it goes into applications. It goes into being able to estimate things. These are all just applications about what's going on with these specific points. And then finally, the last couple things that it wants you to be able to do in here are to translate, which are shift shapes left, right, up, or down, or to reflect points in a plane using either the X or the Y axis. So again, this is pretty straightforward. It's going to be stuff that you might have to check a few things, but I don't want to make you watch a 45-minute video on stuff that you already know, especially since you already know how to do it. So if you have questions, please make sure that you let me know. Save them for class when you come in the next time, and then we can definitely talk and go through whatever you need to go through, because I'd imagine that most of you are pretty solid at this. Because it was a pretty early concept in geometry and a few things that we talked about in Algebra 2. So again, if you have any issues or questions, please don't hesitate to let me know. Hopefully this video was pretty painless. Didn't want it to be something that ruined your night. So let me know if you have any issues, and if anything pops up, send me a reminder, send me an email. I'd be happy to work through them with you. All right, see you later.